So, last week we started with Laplace transform, and we said that it is useful mainly for mathematical computations. It does not have a direct physical significance. It's mainly to solve your systems. You will see it in today's class that what is its main significance. You will solve one of the system, one of the circuit where you will be seeing that we are going to apply Laplace transform. And the main formula was, if you want to take a Laplace transform, so Laplace f of t is equals to f of t e power minus st, and we need to integrate it from 0 to infinity. So this was main formula. Then we moved a little bit forward, and we tried to calculate it for unit step times. So for unit step, we already know that unit step exists from 0 to infinity, and we know that the value of unit step is 1 for t greater than 0, and for t less than 0, it's already 0, so we just put 1. And finally, we came to know that the Laplace transform for unit step function is equals to 1 by s. Similarly, then we move forward and we calculated for e power at. I asked you to calculate, and when we move forward, we just try to put e power at, e power minus st in the formula. Then we combine these two, and one of the clue was that you need to take minus common out of it, so that when you apply limits, it is easy for you to simplify this term. So that's why you can see that when I was doing this, I took minus common, so inside it will be minus is common, so it's minus at. Finally, you applied limits and you came to know that it's 1 by s minus a. So from here, we came to know that if we have Laplace e power at, it is 1 by s minus a, and similarly, if you have Laplace of minus at, so this would be 1 divided by s plus a. So it means that if you have minus on, if you have plus here, so the sign will be changed. Okay. So we move further a little bit, where we try to calculate the Laplace transform for a sine function. Again, I asked you to calculate it. The only clue here was that we split this sine into two exponential functions. Sorry, we initially started with a cosine function. Basically, it was much easier. So you can see that it was just a split. Cos of omega t equals to e power minus j omega t, e power minus j omega t by 2. It's simple Euler equation, right? And from this Euler equation, now you see that you have two exponential, one times this and this times this. You can take 1 by 2 common. So it means that it is not a difficult task, because we already calculated from previous step that if you have e power at and you want to find Laplace is s minus a. So here in this case, you can see that it's e power j omega t. So Laplace would be 1 by s minus j omega, and in this case it's minus, so you will be having a plus here. So it means that it was very simple, and when we finally calculated it, you actually calculated it as s divided by s square plus omega square. So this was for a cosine signal, and now if we do something similar for a sine signal, there are two differences. What are two differences? We know that we have a minus sign here and we have a j term here, which would make you think slightly different in this case. Again, rest I can do the same. So you can see that 1 by s minus j omega, 1 divided by s plus j omega. This was same as previous step. The only thing different is a minus sign in between. In the previous case, you can see that there was a plus sign. Now, if I simplify it, you will get it as omega divided by s square plus omega square. So what is the difference between two? In case of cosine, you have s on the top, whereas in the case of sine, you don't have s on the top. You have omega on the top. Why? Why so? Because when I attempted to solve this for a cosine, if I take LCM, so it would be s square plus omega square. Formula for a minus b into a plus b, and on top it would be s plus j omega minus s plus j omega. So you can see that s is cancelled with s in case of cosine. So that's why, sorry, there is no minus here. So plus. So it means that so this term will come here and this term should go here, so it's plus s minus j omega. So that's why j omega was actually cancelled, and you can see that somehow s would come here. However, in the case of sine, we from here I can clearly see that if this was for cosine, right? This was for cosine. If I write for sine, solve this term, so it would be s plus j omega minus s plus j omega. That means that in this case your s is being cancelled. So that's why in the final equation you can see that we have omega divided by s square plus omega square. So these were two transforms. So you mean probably in the exam, because this is so simple, right? So you can be asked that prove that the Laplace transform for a sine is equal to this. So what you need to do, you simply need to take the Euler formula and then attempt to solve it. For this part, there is no need to solve this again. You can directly say that, okay, we already know the Laplace work, so you can do this direct step. But this is something you can okay, so these were some known functions for which we found the Laplace transform. So now we moving towards some of the properties that are important to know in case we have. We will see that we will going to apply all these properties that we're going to study now. Okay, so if we start with, so you said this area is not visible, right?
Just one hand down.
Here.
No, up more. Yeah, there. Just
Only
one.
this part?
Yep.
Or
That's
here
fine.
is-
That's fine.
Okay, right. So if we start with the very first property is called linearity property. We already saw this property when we were studying Fourier transform. So what does it say? It says that if we have function f of t, and if we have another function f2 of t, and if we say that Laplace for f1 of t was f1 of s, and Laplace for this was f2 of s. So linearity property says that if you multiply anything with their functions in time and add them, the same will apply to their Fourier transform. What does it mean? It means that if we have a f1 of t plus b f2 of t, so what would be the Laplace transform? Linearity property says that you simply multiply this a with f1 of s and b with f2 of s. So it means that we don't need to calculate the whole function again. We just need to multiply a and b with their Laplace transforms, and we get to know what is our final answer. Right. So if we take example here, that would be if we have f of t is equals to $40. So it means that here what we have function f1 and we have function f2. This is your a and this is your b. We know what is Laplace transform for e power minus 8, e power minus 2t, right? We just calculated in the previous step. Can somebody tell me what is for f1 of t? What is Laplace transform f1 of s? What is its value? This is your f1 of t, right? What would be the Laplace transform? What is Laplace transform for this? E power minus 2t. It's written on the board somewhere as well. 1 by s minus a. It means that the Laplace transform for this, we already proved this in the previous steps. In previous steps, you can see that if you have an exponential function if you have an exponential function, so Laplace of exponential function is 1 divided by s minus a. So it means that from this we directly know what is the Laplace for f1 of t. So for f1 of t it would be, can someone tell me 1 by s, 1 divided by s, what would be Laplace transform? If you have a plus here, you get minus here, right?
So minus t.
So it would be plus 2, right? So you can see t is not, doesn't go here, only a comes here, right? So here you have minus 2, so it would be s plus 2, okay? Now tell me the Laplace transform for f2 of t. What would be Laplace transform for f2 of t?
1 by s plus 4.
You can see f2 of t is this one, a is minus 4, right? So if you say f2 of t, so Laplace transform would be f of 2 of s, and it would be 1 divided by s plus 4. So we can simply say that Laplace of f of t is equals to a f1 of s plus b f2 of s, right? I can say this, right? Because I simply apply Laplace on this. This is a f1 of s, b f2 of s, and this would be Laplace for f of t. And I can put these values here, so it's 3. What is f1 of s? It's 1 divided by 2, and similarly b is 5, so it would be s minus s plus 4. So it means that your Laplace is 3 divided by s plus 2 plus, and if you further solve it, it would be we can take LCM, so it would be s plus 2 into s plus 4. So here you already have s plus 2, so s plus 4 will be multiplied, so s plus 4, then comes 5, so here you have s plus 4, so s plus 2 will be multiplied here. So this is basic principle for LCM. So this is your Laplace transform. Have you studied these transforms in any other course?
No.
So this Laplace transform, this is very important. We looking at it, we can analyze what is happening with the system. So I'm not sure if someone of you is from control system, but normally this equation is very significant for control system students. Just telling you that from top equation we get roots, and from bottom equation we get poles. So this equation is very useful for students for control system, that once they get some function in this form, then they tend to find roots and poles, and they check whether this system is stable or not, how this system would behave. Okay, so this was linearity property. Now we will see that what happens if we have derivative in time, so how it will affect the output. Okay, so here we want if f of t has a Laplace transform f of s. So if we have d by dt f of t, which is also represented by f prime of t, what would be Laplace transform of this? So if here the main purpose is that if we know the Laplace transform for f of t, which is f of s, can we directly find the Laplace transform for its derivative? So we need to find what would be the Laplace transform for this. considering the fact that we already know f of x. So we'll see it now. So we know that Laplace transform of any function. So in this case, the function is f of t. So in this case, the function is f of t. So if you want to find Laplace transform, so it would be 0 to infinity. So whatever function will come here, e power minus st dt. So this is typical formula for Laplace transform, right? We just, whatever function we want, we just need to put it here and we solve it. Now you can see that there are two time functions here, time function, and whenever we have two time functions, we simply solve them by integration by parts. In the previous cases for exponential, they were the base was same, so you added the power. So there was no integration by parts, but in this case we would need integration by parts. So for integration by parts, it's very important you identify. So normally we say that u dot v. So u into integration of v minus derivative of u integration of v. So this is the formula, right? So here the important thing is to check to identify which function is which. So let's take this as u and this as v. I will later tell what was the significance, why we have chosen them as this. So now let's solve it. So u is our first function, v is our second function as per our formula, right? And here we have chosen it, u is this one and v is this one. So let's apply integration by part. So it would be first function goes as it, then comes the integration of v. You see here we have integration for v. So if you have a derivative of function f of t, which is f prime of t, if I take integration, if I integrate this function, so if I take integration, so this is derivative, this is integration. So one is derivating it, other is integrating it. Both are reciprocal of each other, opposite of each other. So derivative would cancel integration. Why? Because both are opposite to each other. So we can say that now when we're taking the integration of function from f prime of t, the integration would cancel the derivative and it would turn out as simple function. So here we can say that it is f of t and it is from 0 to infinity. Now coming to second part. So we need to take derivative of u. What is u? U is this function. So if we take derivative of u, it would be e power minus st. So in terms, what is derivative for e power at? So derivative of e power at is equals to e power at times a. Right? This is derivative. In integration we divide it, but in derivative we simply multiply. So in this case a is minus s. So you will get minus s here. And so it means that we have taken the derivative.
Integration v.
Yes, so now the next step is that we need to take the integration of v. Okay. So again, when we take the integration of v, you see that integration would cancel the derivative, same as this step. So when we take integration of a derivative, integration and derivative are opposite to each other, they will cancel each other. So we can say that it would be f of t dt and we have an integration here which is from 0 to if I solve it further, e power minus st f of t, so limit is 0 to infinity, this minus would be plus e power s e power minus st f of t dt. It's clear so far, right? We just taken two functions, so derivative, so yes, same function, then its integrator, then we take derivative and then integration of v. Integration of v. So integration of v was the same function. Now we can apply limits here, right? So if we apply limits here, it would be so e power minus infinity f of infinity minus e power 0 f of 0. True? This is how we apply limits on t.
It's going to be 0.
Then it would be s integration 0 to infinity e power minus st f of t dt. Can someone tell me that what is this? After s, what this formula shows you? This is Laplace, right? This is formula for the Laplace, and what is the function inside? F of t. So it's mean that here, before going to that, let's solve this one. So e power minus infinity is 0, so this term would get as 0. This e power 0 is 1, so we will get it as minus f of 0. Then s, and this is your Laplace, so we can say that f of s. Or we can write it in more appropriate way is, so it means that if you have function f of s, if function f of t, and you know the Laplace f of s, what you can do, you can simply multiply s with the Laplace and subtract f of 0. Now note that this f was a time function, right? So it means that you need to put t equals to 0 in time function and put it here. This is not f of s, this is f of 0, and the limit was on t. So it means that this is f at t equals to 0, where this is s, f of s. Any question on this? So it means that we came to a formula which is if f of t is f of s, f prime of t would be s f of s minus f of 0, where this is value of function at t equals to 0. I haven't seen you before. I'm not sure if you are in the right class. Just asking.
My course admin has some issues with allocating my correct modules, and only now they finally done that. So
Okay, yeah. I was just making sure that you're not in the wrong class.
I
So
understand.
that's okay. That's fine. Yeah.
You'd be surprised with a lot of stuff in this universe.
I can confirm, but he's if you don't know him from.
Did you do the analysis?
Yeah, I'm not sure how you can. If you are
Cool.
not.
Keep calling me.
Give this. So I can't do it. This will do it. Then I'll keep it.
Let's take an example and see.
Excuse me.
Okay, if f of t is equals to sine of omega t. So, what is Laplace for this? What is Laplace for sine of omega t?
We did last week.
Yeah, but we want to do it.
We have done it, right?
Yeah, we did last week.
Yes,
Yeah.
we calculated it, right? And I explained it today. Sorry, what?
Was it omega?
Divided by s.
S.
Yes, s square plus omega square, right? So it is omega divided by s square plus omega square. Just for the sake how to remember it, since you have a sign here, right? So there is s already, so you will not be getting s here. So in terms of cosine, you know that Laplace of cosine omega t is s divided by s square plus omega square. So just to show you that how you can memorize it, that you have s here, so you will not be getting s here, but in terms of cosine you will be getting s. Okay, right. So it means that we know the Laplace transform for f of s. So what if I am being asked to find Laplace transform for f prime of t? So I need to calculate Laplace for f prime of t. What is f prime of t? We know from here, right? F prime of t is, if you take derivative of this, it would be
Cos omega t.
so it means that we know what is our f of t, right? So we can check this now in two ways. One way is by formula, by direct the way we learned. So we know that if f of t is f of s, f prime of t, we don't know, for example, the function. So we don't know the function at the moment. So f prime of t would be equal to, so for this the Laplace would be equal to,
S time.
yes, so Laplace of f prime of t is equal to s times f of s minus
Absolutely.
f of 0. So we know what is f of s, right? What is f of s? Omega divided by s square plus omega square times s. Now, we know what is value of function at 0. What is value of function at 0? What is this? How are we going to find this? How are we going to find this? What I told you, that in order to find this, you just need to take time domain function and put t equals to 0. What is time domain function?
Ft.
Which one is it? This one, right?
Yeah.
So
Sine of this.
sine of t. When you will put t equals to 0, it would be sine of 0. What is sine of 0?
0.
0, right? So it means that the latter term would turn out as 0. Okay. So it means that the transform is omega s divided by s square plus omega square. So it means that from the derivative formula we came to know this. Now let's find Laplace directly for the derivative, because we know the derivative function, right? Let's do it in a direct way. So we know that f of t is, so if you find f of t, it would be omega cos of omega t. This is f of t, right? Now we can find Laplace transform for this, right? How? So if I find Laplace transform of f of t, it would be Laplace transform of omega cos of omega t. Omega is constant, so it would be Laplace of cos of omega t. What is Laplace of cos of omega t?
S by S square plus
S divided by s square plus omega square, so it would be omega times s square divided by s square plus omega square. So you see both are same. So it means that the thing we said, that whenever we have a time domain function and we want to find we want to find its Laplace of its derivative, we simply need to multiply f of s with s minus f of 0. It would result in the same thing if we have taken the Laplace of its derivative directly. Okay? So it means that we proved that this equation holds. So from here we came to know that Laplace of f of t is s f of s minus f of 0, right? What if we have a double derivative? What if we have a double derivative? You know what I mean by double derivative, right?
Yeah, it's like a derivative of derivative.
Derivative of derivative. So what if you have a double derivative? So for double derivative, it will be s squared f of s minus s f of 0, small prime in 0 minus f prime of 0. I will explain what. So if you have, in case of single derivative, it was s f of s, and you simply take the function, put time equals to 0, and put it here, like we done in the case of sine. So we simply multiply f of s with s, and sine 0 was 0. But if you have a double derivative, what you need to do, you need to s square f of s, here f of s, so it is double derivative, makes sense to have a square f of s, minus s, since now we have two derivatives in the function, so we will be having another s, f of 0, this is, what is this? This is f of t at t equals to 0. And then this is derivative of function. So f prime of t at t equals to 0. So it means that here you will directly put t equals to 0 in the function. Here first you will take the derivative of time domain function and then put t equals to 0. Okay, this is how we find the double derivative. And similarly, if we have derivative 3 times, so it would be s cubed f of s minus s square f of 0 minus s f prime of 0 minus f double prime of 0. So it means that it follows the same trend. You just need to see which derivative it is, and then you can follow this trend. The journal formula for this is mentioned on your lecture slides. Okay, now let's move further and see what if you have f of t, you have f of s. So what if you have integration? So what is the Laplace transform for this? So if your function, it is integrated from certain limit from 0 to t, f of t dt, then what would be the Laplace transform? So I want you to trust me on this, and we will not go into derivation, and I will simply say that it is 1 by s. So in case of derivative, it was s f of s, and in case of integration, we simply say that if you have a function f of t, you know the Laplace is f of s. If someone want to ask you to find its Laplace from the derivative, you simply need to divide it by s. And I will not go into derivation for this. So this was integration. Next is time shift. We will apply these properties. We will do some examples by the end of the class, and we will apply all these properties so you know what we are actually talking about. So again, if you have f of t and the Laplace is f of s, so what if you have t minus t naught? What would be Laplace? So if you have shift in time, how it will affect your Laplace, right? Okay, so let's take help from formula of the Laplace. So Laplace of f of t minus t naught is equals to 0 to infinity f of t minus t naught e power minus st dt. Typical formula for the Laplace, right? And now we need to find what happens if we have this function. Now we don't know the function, right? So how we solve it, if you remember a little bit from Fourier series, what we did, we replaced it with another variable. So let's say that lambda is equals to t minus t naught. Let's assume that lambda equals to t minus t naught. So it means that we need to replace this part, which would be lambda. We need to replace t as well, because now it's a new thing. So from here, we can say that t equals to lambda plus t naught. We can simply rearrange it, right? Now, the last thing is dt. We need to replace dt. So if I take derivative, it would be dt, it would be d lambda, whereas this is constant, so it would be 0. So it means that I can simply replace dt with d lambda. So now, it would be 0 to infinity f of lambda e power minus s, and instead of t I will be writing lambda plus t naught dt. Okay, finally, if I solve it further, it would be 0 to infinity f of lambda. I can break this, it would be e power minus s lambda, e power minus s t naught dt. Now you can see that from here we can see something. What we can see is, if I bring it here, it would be 0 to infinity f of lambda e power minus s lambda times e power minus s t naught dt. So you can see from here this portion with dt. What is this? This portion with dt. What is this? What is for this? What formula it shows? This shows formula for the Laplace, right? Instead, it's not t, it's just lambda. F of lambda e power minus lambda. Sorry, this was not dt, this was lambda. We already changed it here. So this was lambda, this was lambda. So it means that overall, this and this combined is a Laplace transform. So it means that if I write it a little bit in more sophisticated way, it would be 0 to infinity f of lambda e power minus s lambda d lambda. Why? Because t naught was constant. There was no lambda, and so I took it out. So it means that this term is the Laplace transform, right? So I can say that it is equals to e power minus s t naught f of s. So it means that if you have a time shift of t naught, if you have a time shift of t naught, same sign will go in the power e power minus s t naught and would be multiplied with f of s. So if you have a function f of t and you know the Laplace transform, you simply need to take the shift into the power of e power minus s, that shift, and it will give you the shifted version. If in your lecture slide, instead of T naught, I have used it as tau. So it's the same thing. It would be just if T minus tau, it would be e power minus s tau f of s. Here you can see that same sign come to the power of s. Any question on this? Next thing is multiplication by e power at. So imagine that you have a function f of t and you know the Laplace, which is f of s. So if you have e power at f of t, what would be the Laplace transform? Why we are learning these properties? Because these are some of the common functions that you would see whenever we will be solving any system or any practical system. I would say that any circuits you need to solve something, you will see such kind of system. So imagine that you have function f of t and you have Laplace f of s. So what if you have if you have e power at multiplied with it? So let's take help from Laplace. So we know that Laplace e power at f of t is if whenever you are given with any function and you are asked to find Laplace, try to find some tricks. For example, if you know the Laplace already, for example for e power at, but if somehow you cannot remember, always take help from Laplace actual formula. It will give you the same thing. Okay, so here it was, one thing was missing, which is e power minus st dt. So this was your actual function for which you want to calculate the Laplace transform. Okay, so it means that I can solve it. So it would be 0 to infinity f of t e power minus st plus at dt. Right, if I take 0 to infinity f of t, if I take minus s common, so it would be, so if I take minus t common, it would be s minus a t. So if I take minus t common, inside it would be s minus a t dt. So it means that from here we can conclude something. What we can conclude is, again we can do those shift thing with with these variables, but here what we can see is, we know that if you have f of t e power minus st dt, it gives you f of s, right? This is typical formula for the Laplace. So now you can see that here something has changed. Instead of s, you have s minus a. So I can say that if you have f of t e power s minus a t, so only this s part has changed. So I can say that this belongs to s minus a. So it means that if you go with the basic formula for the Laplace, it says that f of t power minus st will give you f of s. So in this case, what has been changed? Instead of s, now you have s minus a. So simply replace this s with s minus a. So from here we will get to know that it is equals to f of s minus a. So if it's mean that if your time function is shifted by e power at, you just need to shift its s by opposite of a, e power at. So you can see that f of s minus a. You don't need to do all the calculation again. You can simply say this. One last property, and then we will do some examples. Then is multiplication by t. It means that if you have a function f of t and you have Laplace f of s, if your function is multiplied with t, what would be the Laplace transform? Again, let's start with the formula for the Laplace transform. So we know that if we have f of s, it is 0 to infinity f of t e power minus st dt. This is the formula for Laplace transform. If we integrate both sides with respect to s, it means that if we take d by ds of both sides, if we integrate it. So what would happen? It would be d by ds f of s. Now here you can see that this is f function of time. So this is for d by ds, it will behave as constant. Similarly, integration is on time, it will behave as constant. So you can write it as 0 to infinity, f of t will behave as constant. However, this is function of s, so we will take derivative of it. So if we take d by ds e power minus st. So now the function for the variable for which the derivative is taken is s. So it would be e power minus st, and then again the derivative of this part, right? So which would be d by ds minus st. So now the derivative is taken with respect to s, so you will be having a minus t here. You understood this, right? It's just that we are not taking derivative with respect to time, we are taking derivative with respect to s, so s will becomes 1 and t will minus t will become come on the back end. Okay. So same thing would apply here. So you have minus t e power minus st, and dt would not change because this is not the function of time. Now if we write it 0 to infinity t f of t e power minus st dt, only minus is left. So if I take minus on the other side, it's just the same, right? Or multiply minus on the both sides. So it's mean that now looking at this again, I can see that it is somehow Laplace equation, but for what? Here the function is this. It's mean that if I take this as a function, then rest is the Laplace operator. So it tells us that the Laplace of t f of t is equals to derivative of f of s with a minus sign. So it's mean that if we write it here, so Laplace of t f of t would be equal to minus d by d f of s. So it's mean that if you have f of s, you just take the derivative and multiply it with a minus sign, it will give you Laplace for t f of t. So it's mean that if you have a function f of t and it's multiplied with t, you simply need to take derivative of its Laplace, multiply by minus, and it will give you its Laplace transform. Let's take some examples to show all these. we just studied that if some function is multiplied with t, Laplace of t, f of t is equals to minus d by d s f of s. Okay, so who will find Laplace for this? Start this, finding Laplace. Take this is your f of t, right, in this case. And you all know that what is Laplace transform for a unit step? What is Laplace transform for a unit step function? Anyone? What is Laplace transform for a unit step function? Yes, what is Laplace transform for unit step function? We done it in the first lecture, right? So Laplace transform of unit step, it should be on your fingertips by now. 1 by s. If you have unit step function, it is 1 by s. And we saw it, I explained it today as well, and we saw it initially. Solve it initially in the first, in the last week lectures. You can see we solved it here that the Laplace transform for u of t, which is a unit step function, is equals to 1 by s, right? It means that now you know what is your f of s. So in this case, we know f of s is Laplace of f of t, which is Laplace of unit step, is equals to 1 by s. So it means that your f of s is 1 by s. So solve it. It's simple. It's very simple. So Laplace of t, u of t would be equals to minus d by ds of f of s. And you know what is your f of s. So solve it. You just need to take derivative of 1 by s. Here the main hint is that you just need to bring it like s power minus 1 so that you can solve it by the property of derivative.
Is it just minus f of 0?
What?
Zero comes from?
No, isn't it minus 1 of f over s squared?
There should be no minus, but 1 by s squared is fine. Minus should go with something.
Oh, is it? Does it cancel out?
Goes with the minus in derivative. Minus t.
Oh, yeah, so cancel out.
Yeah.
So it's d by ds. Minus is outside and inside is s power minus 1, right? So what is derivation? What is rule for derivative? Power comes back and then it is subtracted with 1, right? So it would be minus, and inside it would be, sorry, minus into minus 1. So derivative rule is d by dt, t power something, so it would turn out as x t power x minus 1. So this is how we do derivative. So here in this case, power will come back, then it will be s minus 1 minus 1 So it would be 1 times s minus 2 or 1 by s square. It was simply taking a derivative for s power minus 1, and normally we take derivative using power rule, which is this, and then it comes out as 1 by s square. Any question on this? Any confusion? Okay.
Okay, if
Okay, since there is no confusion, let's move to next one and solve this. Which is Laplace for t e power minus at u of t. Here you need to apply two properties, so just solve it. You know what you have to do here, right? You know Laplace for u of t. What is u of t? Laplace for u of t?
1 over s.
1 over s. Then you know that when anything is multiplied by e power minus at, what happens?
It's going to be 0.
No? We just saw previously that if e power at f of t for this Laplace is s minus a, right? We just calculated. Okay. So in this case, you know that for u of t, what is Laplace transform for u of t? For u of t is
1 over s.
1 over s. For these two would be simply replacing s with s minus a, right? Sorry, s plus a. So we know that Laplace for u of t is 1 by s. So if we simply multiply it with e power minus at u of t, so it would be 1 divided by s plus a. So it means that for these two, we simply calculated Laplace by the properties we just know, right? No confusion, right? Okay. Now the third part is, you will find that for me. So you need to multiply t with this. So when we multiply t with this, so now this is your f of s, right? So you need to take derivative. So take it. So imagine that now this was your f of t and this was your f of s. So the next step is you have multiplied t with e power minus at u of t, which we consider as our f of t, and you have to find Laplace for this. So it would be d by ds f of s, and your f of s is this. So solve this. Again, we need to take this top to make it, to take the derivative. So it is minus d by ds, and f of s is 1 divided by s plus a. To take the derivative, I will bring it as s plus a. So it's now again easy to solve. You can solve it.
plus a square.
A whole square, right? Because here minus would come on the back, it would become plus, and it would be s plus a minus 1. So it would be s plus a power minus 2, which would be 1 divided by s plus a square. There was one more way to solve it, which was even easy. How? We know t u of t. What is transform for t u of t? We just calculated it's 1 by s square, right? In the previous example, it was 1 by s square, right? There was another way to solve it. What was that? We just calculated that t u of t Laplace was 1 by s square by using t times u of t was s, and then we calculated, right? And if now we know this, so if you multiply e power minus at with this function, we simply know that whenever we multiply e power minus at with anything, and we already know its transform, we simply need to replace s with s minus a. So we simply replace s with s minus a. So this was another way to solve it. It's just that which way you were using. So we knew t u of t is 1 by s square, or you can solve it. It was easy by taking derivative. And next step, whenever any function is multiplied with e power minus at, and if you know the transform for that function, so now your function is this whole thing. You know the Laplace transform. So you simply replace s with s plus a. Right? So this was another way to solve. Next is I want you to solve on your notebooks Laplace of e power minus at cos of omega t. This is quite simple. You don't need to solve it. You know what is Laplace of transform for this, and you need to shift it with something. Just solve it. Take f of t equals to cos of omega t. Solve, f of s for f of t, and you just need to do time shift. So time shift e power a. What is Laplace for cos of omega t?
And then s over s squared plus omega squared.
And you just need to multiply it with e power minus at. What happens when we multiply with e power minus at?
S minus a?
S is replaced by s minus a. So everywhere s you will replace it with, s plus a, the opposite of a. It's minus a plus a. So replace everything with, simple, right? So cosine, you have s on the top.
Yeah. Then you replace it.
Yes. This, you written this s.
Yeah, it's just.
Quite hard to read if you have s. It looks like one.
Oh, it's just.
That is right there. So everything is fine except this is plus because this is minus, so we will get plus, right? Yes, good. So you know the Laplace. Now when you multiply with e power minus at, so what happens in your Laplace for this, s is replaced with s plus a. So replace it. Everywhere else, wherever you find s, you will replace it with s plus a. So just put an equal to here. Yeah. There is no omega. In cosine, we don't have omega. Yeah. Yeah. Replace s with s plus a. Yeah. Good. No, you have s here as well, right? Yeah, everywhere you will find s, you will replace it. Now there is a square here, it's square, right? S times, yeah, so you need to take whole square, yes, now this is square. No, you just need to replace S with. No, you have. No, the Laplace, so what is Laplace for, only this term, right? You just need to, you don't need to write this thing, okay. This incorrect, yeah, again incorrect. You just need, for this whole, to find for this whole thing, you know, for cos of omega t is this one. So you just need, for finding for this whole thing, you just need to replace S with S plus A, so you will get this for the whole thing. So, put n equal to here. Yeah, start replacing S with S plus A. S plus A, y, yeah. Yes. The way you were doing here, you were just multiplying to Laplace transform. I mean, ultimately, if you solve it, you will somehow get this thing, but it's not the right way to mean it, right? So it was very simple. So you just need to consider this as f of t, and we know that the Laplace for f of t is s divided by s square plus omega square. So it means that we know Laplace for f of t. So if you multiply this f of t with something which is e power at, what happens with its own Laplace? S would be replaced with plus a. So s plus a divided by s plus a. So this is how you get it, okay? Right. Who will find if I have Laplace of e power minus at sine of omega t? Who will find this, considering we already find this one, right? It's quite simple. If you have e power minus at multiplied with sine, what would happen?
It's going to be opposite.
It'll just be, the top will be omega.
Yeah, tau would be omega. The only thing different would be the tau would be omega, because for this f of t, which is sine, we know that the Laplace is not s here, it's omega divided by s square plus omega square. So replacing thing would occur only in the denominator, and you get omega on the top, right? Okay. It means that we came to know some of the main thing. We haven't calculated a Laplace for delta of t, which is Dirac delta function. If you remember, the Fourier transform for Dirac delta function was a straight line, which is 1. So same holds here. The Laplace transform for Dirac delta function is also 1. Then we did calculate for u of t, which was 1 of s, right? So this kind of table you will probably get not probably, you will get it in your exam.
So we don't have to derive any period or anything.
If, for example, I say that show that the transform for u of t is 1 by s, then you have to use the formula and derive it, right? But if, for example, in the previous example, e power minus at cos of omega t, then if I say use e power minus at shift property to calculate, so you need to take, for example, in the previous case, you need to take cos of omega t from the table, and then you can say that, okay, I applied the shift property. But again, even you have the shift property, but you have to show some steps, right? but this table you most probably will get. You can see that e power minus a, e power 1 plus a, if you have minus here, it comes as plus, if you have plus here, it comes as minus. Then for cos of omega t, you have s divided by s square plus omega t, sine of omega t is omega divided by s square plus omega square. This we now just calculated. If you have cos of omega t multiplied with e of t, you just replace s with s plus a, s with s plus a, here it comes. If you have sine, so you don't have s on the top, you only have s in the denominator, so you write s plus a whole square plus omega square. Then we also calculated for t u of t, it's simply written t, right? It's t u of t. So we know that Laplace transform hold from 0 to infinity, and u of t is 1 for that. So normally we say even it's t or u of t, it's 1 by s square, right? Okay, right. And so this table you will get. Any question? Any confusion on this one? T equals to 1 by s square. No, right? Because t u of t is equals to t for t greater than 0 and 0 for t less than 0, right? And we already know that Laplace transform only hold for 0 to infinity if we go into the formula for Laplace transform. So that's why if we write it as t u of t or if we write it as t, both are the same thing for this specific case. Right, so it means that we going to get this table. Now as I explained that Laplace transform is more like a mathematical operator which gives you simple analysis. It means that in order to solve a circuit which is in time domain, you find difficulty in solving it. So what you do, you find it in using Laplace theory, the same way we have done. And for example, you know that most of the equations, they are differential equations, so they have derivatives. So we know that how to solve derivative using Laplace, s f of s. But the thing is, once you solve something using Laplace, then you have to convert it back to time domain to see it, right? So it means that Laplace is just to analyze something, but we want to bring it back to time domain as well. So it's very important to learn how to find inverse Laplace transform. Initially, if you remember, we showed this formula for inverse Laplace transform, which is very difficult or impossible to solve. So we will find some other ways to find inverse Laplace transform. Those methods are called by inspection. What does by inspection mean? If, for example, I have solved and I get 1 by s. If I solve the circuit and the final equation was f of s equals to 1 by s. Now I know that what is the time function for f of s. I know that for f of s, the time function is u of t. So it means that by inspection, I can look at the Laplace domain and say this is how its time domain looks like. If, for example, finally, if I get this equation and someone asks me to find inverse Laplace transform, so I know by inspection that this is Laplace for e power minus at. So it means that in practice, whenever you solve any circuit, you finally get an equation in terms of s because you are solving it using Laplace. So then you try to arrange that equation using known formulas, using known things, so that then you can reconvert it to as an inverse Laplace transform. So this method is basically called method by inspection. We will see then there are 3 different things in this case. We will see it now. We'll solve it by hands rather than going through slides. Okay. So first example is if we will later on see that how we solve a circuit using Laplace, but let's assume that I am writing a f of s equals to let's say that we solved a circuit and we get this final equation. Now we want to convert it back to time domain to see that what was this system. So imagine that you were having, for example, an electrical circuit or any other circuit, and you solved it and you finally came to this formula. And you want to see that how it looks like in time domain. It means that we need to take inverse Laplace transform. So how we proceed with inverse Laplace transform, we'll see it now. So to proceed with Laplace transform, as I said that we need to somehow make it known formulas. And to make them known formulas, I just previously said that if, for example, if 1 by s plus a omega divided by s square plus omega squared, we need to make them look like known formula. So it means that in order to make it something like this, we need to factorize the denominator. Okay, in some cases, in most of these cases, we will solve denominator. Why? Because this denominator is the main problem which would not allow us splitting something. So have you studied partial fraction? I'm sure you did in some stage of maybe in A level, O level or somewhere. So we will apply, first we will solve this denominator, factorize it, and then we will apply partial fraction. So the very first thing is to solve the denominator. So s cubed minus 7s minus 5 okay, if I write it s cubed minus 1, this is 6. Minus s minus 6s minus 6. It means that it's the same thing. It's just that I split it these. This is how we actually factorize. We split this thing so as to get the. If we sum these, it would remain the same thing.
Is it like multiplying the first one and the last one? And
Yes.
then-
Yes, it's the same way. And if you take s, it would be s minus 1. Here, if you take 6 out, it would be s plus 1. Then
So wouldn't it be s
I think
squared?
it should be
Yes.
squared.
yeah, you're right. Then it would be s. I know that this is a square
I think it should be
minus b.
6 squared. I think it should be 6 squared.
Where?
Minus 6 instead.
This?
Yeah.
No, it's just 6 taken common. Here it was s common, so here s squared minus 1. Here 6 is taken common, so s plus 1.
Oh yeah.
Yeah? Okay. Now I know that this is formula a plus b into a minus b, a square minus b square. Same thing I apply here, it's s square minus 1 square. It would be s plus 1 into s minus 1. So it would be s plus 1 into s minus 1 minus 6. This is slightly, denominator is slightly different, but most of the time in the denominator you have quadratic equation, so solving roots for quadratic are much easier, okay? Then from this, if I take s plus 1 common, so it would be s plus 1. Inside here it would be s into s minus 1, and here it's minus 6. S plus 1, s squared minus s minus 6. It would be s plus 1. Again, we need to do something here, so you can write it as minus 3s plus 2s minus 6. Then in the next step, we can take s common from here, so it would be s minus 3. We can take 2 common from here, it would be s minus 3. and then finally it would be s plus 1. If we take s minus 3 common, it would be s minus 3 into s plus 2. So it means that we factorize it as s plus 1 into s plus 2 into s minus 3. So if you multiply them again, you will get the same equation.
I have a question. You know, if the cubic terms, I mean the denominator, if it had all the powers, so from 3, 2, and 1, would your method still work? Or splitting?
No, then we need to apply another method in which we, I don't remember the name of the method, but in which we just take the powers and we use a different way. For example, we write 0 in power 3. What that method is called, I simply forget the name of the method. But no, this method would not work, yes. Okay, so it means that we split our denominator. So the very first task in doing inverse Laplace transform is to solve the denominator. So it means that I can write it as 2s squared plus s plus 5 divided by s cubed minus 7s minus 6. So I can write it as 2s squared plus s plus 5. Here I take s plus 1. What was the others? S minus 2, s plus 3.
Minus 3 and plus
Yeah.
2.
So it was plus 2 and minus 3. So it means that now we have this thing. Now another part is to split these terms. By splitting I mean so that I can get this separate, this part separate. I can do that by writing it, this whole equation, I can write it as a divided by s plus 1 plus b divided by s plus 2 plus c divided by s minus 3. So it means that I have splitted them in this way. This is true only if I find a using this equation, a, b, c. So at the moment I don't know a, b, c. I will find them using this equation. So this setup is called partial fraction. So if you want to split these terms, you just write this whole thing equal to a plus b plus c. Underneath a you have first, second, third, or it can be other way around. Right. So now what we need to do, we need to solve this equation. So it means that I have this equation both. So the very simple way is to cross multiply things. It means that if I cross multiply it here, it would be 2s squared plus s plus 5 equals to a. What would come in here?
S plus 2 and s minus 3.
Yes, because s plus 1 would be cancelled with s plus 1, and it comes out as s plus 2 and s minus 3 plus b divided b into s plus 1 s minus 3 and then finally c would be s plus 1 into s plus 2. Okay, now it means that we have this equation that we can use to find a, b, and c. So we have this equation number 1 which we can use to find b. So now see that all these values are different than each other. So basically these are called roots. So basically, all of these roots are distinct. They don't have, they have different values. So here you can see that if I want to find roots, so here I would have roots s equals to, roots means solution for the equation. So here you can see it's s equals to -1, -2, and +3. If how I find root, I simply take each one and equate it to 0 and find root. So it means that here you can see they have distinct roots, different roots. So the method we are using now is for distinct roots. We take each root. So let's take s plus 1 equals to 0. This means that s equals to -1 and put in equation 1. Put in 1. So it means that in this equation, when I put s plus 1 equals to 0, clearly s plus 1, 0, this term would get at 0, this term would get at 0. Only thing left would be this one. And here, now in this equation, I can put s equals to -1 because this was the actual thing. So if I put 2 into -1 square plus -1 plus 5, a into -1 plus 2 -1 minus 3. If we solve it, 2 minus 1 plus 5 equals to
-1.
here. So finally, you will get it as
It's 2.
-2.
I think you changed the sign. At the beginning it was -s and then you wrote +s.
Which one? Sorry.
In the question.
First,
Oh yes. Sorry.
and then you did the +1.
Thanks for that. Okay, so it means that it's a equals to -2. Then the same thing we will do for second thing. We will take s plus 2 is equals to 0, right? And we will put it in the same equation. When we will put s plus 2 equals to 0, this term will go away, this term will go away. Only thing would left with this part. So it means that here s equals to -2. So it would be 2 into -2 square -2 and so now we have b term active, so it would be -2 plus 1 -2 minus
3.
b, yeah, yeah, b3, sir. So value of b you will get it as 3. And then finally for the third case, what we're going to do, we're going to take the third root, which is s minus 3 is equal to 0, so s equals to 3. So you can see that in this case, these two terms will go 0, the only term would left is this one, so it would be 2 into 3 square minus 3 plus 5 is equals to c into 3 plus 1, 3 plus 2. And you will get c as 1. So this from here you will get c as So it means that now we have found A, B, and C. This means that now this equation holds. We can simply put A, B, and C. in this equation. So it means that I can write f of s now as, what was the value of a? A was minus 2 divided by s plus 1. Then the second thing was, what was the second thing?
3.
Yeah, so 3 divided by s plus 2, and then the last thing was 1 divided by s minus 3. So it means that now this function is in a format which I know, right? So what would be inverse Laplace transform for this f of s? So minus 2 is constant, right? 1 by s plus 1. What is inverse Laplace transform for 1 by s plus 1? I know that the Laplace transform for e power at is equal to 1 divided by s minus a, right? So what would be here? E power
S minus
Uh,
minus 1.
should be
it should be plus t or minus t?
Minus 3.
Minus t, right? Because we take the opposite signs. So it would be minus t. Then 3, what would be this one?
E minus 2.
Minus 2.
Same thing.
And last one?
E plus 3t.
Plus 3.
3,
Right? So this is your inverse Laplace transform. And this function is for t greater than 0, which we know that's because Laplace holds for t greater than 0. So it means that the crucial part, there was two things. One was to get a factorized equation, and once you have that, apply partial fraction. And this partial fraction method, in which we take a divided by s plus 1, b by s plus 2, c by, this is only when we have distinct roots. It means that all of the roots are different than each other. Now we will take another example quickly, in which we will see repeated roots. Okay, so now we have repeated roots. F of s equals to 1 divided by s plus 1 whole square. So, in case of repeated roots, the only thing different is how we write this equation in terms of a, b, and c. So,
There is no p. Then
s plus 2 is straight away, we can write it, right? So I will write it first as c s by plus 2. Now the problem is with these two. So for this, what we do, we take it a divided by s plus 1 whole square plus b divided by a power lower than this. So this is how we write when we have repeated roots. For repeated roots, we take the maximum power, then b divided by the lower power, then c divided by lower power, and so on, if it was a cube. Now, again, partial fraction, so it would be 1 is equals to a divided by s plus 2. For partial fraction, we just multiply it here, plus b into s plus 2 square plus c into s plus 1.
Wait a second, how does it equate?
Sorry,
Uh,
we simply multiply it on the other side. What's your question again?
it's alright.
Why, how we equate them, right? This is what you, because at the moment we have unknowns in this equation. So once we find unknown using the same equation, it means that the equation will hold.
Surprisingly, what did you do from the s plus 1? Because you said s plus
I
1.
think it should be s plus 1. And then if we multiply it, it becomes s plus 1 cube.
Where?
This one.
No?
So all this thing go into numerator.
Okay.
So s plus 1 square divided by s plus 1 square would cancel with each other and would left with s plus 2,
Alright.
right? Because this goes to on the numerator, not in the denominator. Similarly, here it will go on the top. 1 square term will. Okay, so here. So here it's b into 1s plus 1 would be cancelled, yes, and second would remain here. I think here was a mistake. Then c into s plus 1 square, right? That's correct. Okay, let's take on this. So in this case, we don't take roots and put it. No, we don't use that method. That method was only for distinct roots. In this case, we will open this equation as whole and we'll see as plus 2a plus b, and we can solve it on the side.
So they're going to be s squared.
S square plus
2s plus s plus 2.
2s, no, plus 3s. Okay, I mean I was writing as a whole but only. S square plus s plus 2s plus 2. So it would be s square plus 3s plus 2, right? Okay, so it would be b s square plus b 3s plus 2b. And this we know that, right? cs square plus 2cs plus c. This is simply the formula, right? Now we need to separate each power, so need to take square
Can't you, okay, cancel out.
a plus b, no, a plus, okay.
So are we equating coefficients now?
Yes, so once, first we will separate powers and then we will equate b plus c s square, then is s, so a, 3b and 2c.
Uh-huh.
A, 3b and 2c. S and last is constant. Yes, so it means that now we have this with s squared, this with s, and this is your constant. Now we can equate it on the other side, right? On this side, if I write it is 0s squared plus 0s plus 1, right? If I write this equation, there is no problem. 0 times s squared is 0, 0 times s is 0, 1. I written just to equate them. So you can see that here is s squared, here is s squared. So this coefficient is equal to this. So it means that equating b plus c is equal to 0, because on this side there is no coefficient of s, so it means that it's 0. Then the second equation is a plus 3b plus 2c is equal to 0, whereas the last one is lucky, it has 1 on the other side, right? So it means that now we have these three equations. Now we have three equations here unknowns. They are easy to solve. You can put them on top of each other, or you can take b equals to minus c and then you can solve it. You can do that, right?
Yeah.
Okay. It means that from here we can find a, b, and c. The a, b, and c that we get from this is A equals to 1, B equals to -1, and C equals to 1. So this is what we needed actually from these equations. So if I take B equals to -C, put it in this, then solve them two, then put back and forth, you will get A equals to 1, B equals to -1, and C equals to 1. Now it means that our problem is solved. So it means that now the problem is solved. Now we can write this equation as A is 1, so 1 divided by S plus 1 squared, B is -1, S plus 1, and C is 1, S plus 2. Who will find inverse Laplace transform? Okay, just tell me what would be the inverse Laplace transform for this part?
So just e to the minus 2t.
Yes, for this part?
Minus e to the minus t.
Minus t, yes. What is for this part?
Times t.
Yes, times t. Right?
Okay.
What times t?
T e to the minus t.
T times t, yes. Because for t, it's 1 by s squared. Then if you multiply e power minus t with it, it would be 1 divided by s minus 1 squared, right? So for these two, it was quite simple, right? So for this one, we know that it's e power minus 2t. For this one, it's e power minus t plus and minus. For this part, we know that Laplace for t is 1 by s squared. We know that if you multiply this Laplace with minus a t, it would be s shifted with plus a, and you will be squared. I want to make it like this. Okay, if there is a, so here it would be s minus a. So same thing is here. I know that 1 by s squared is for t. I can write t, and now from this I can see that it has a shift. So t e power minus t. So this would be your overall Laplace transform, inverse Laplace transform. So this was for repeated roots. Next week, hopefully, we will try to finish with signal processing part so that we are able to start AI in 7 weeks.
I think I'm going to be ill next
Sorry?
week. So I think I'm going to be ill next week. So.
It's a face test on week 8.
Week
Seven.
7. Week 7 is Thursday. Yeah.
Nothing good.
Before you move, I just want to show you something because we have a lab today, right? So I just want to show you something. I will show you in lab as well, but
Wait, so you said week 7 is the face test.
sorry?
Yeah.
And this will consist of everything we've learned, like since
Yes, but when I will finish tomorrow, hopefully finish tomorrow by signal processing part, then I will explain to you that
Next week.
Maybe next week.
what we should cover for.
Okay. Are you giving us all topics to revise, or are you giving me specific topics?
I will try to give you specific topics because I know whole topics will be
Because
different.
it's a tool of each.
Yeah, they don't worry about it. I will.
Yeah, make our life easier.
Because some of our lecturers are tricking us, you know, they give us other topic and then
Stop
test
us.
us another topic.
Who's that like?
Who's picking me?
Stop. I didn't have to say it.
No, hopefully I will say the main.
Let's take the. He's a cheater, man.
You fucked me over. Big time. I've done his 5 labs, he didn't even mark.